Our sun is 91 million miles away from us, yet even from that distance, the star has an incredible impact on humanity. Scientists have always been supremely fascinated by the sun and have always wanted to know more about it. We know how hot it is, we know how large it is too, but we don't have a lot about what makes it tick or why it acts the way it does. I'm sure you can understand why having full knowledge of the sun would be so tricky. It's not like humans can fly really close to it. Anything that gets even millions of miles away is destined to be burnt up. That's why the Parker Solar Probe from NASA is such a big deal. Not only is the probe getting remarkably close to the sun, but it's also sending back information that is giving us a better idea of how the star works. The Parker Solar Probe is the first man-made object to touch the sun's outer layer, and the recent findings from the mission seem to have left NASA with more questions than answers. Let's take a look into NASA's Parker Solar Probe and learn why its newest discoveries have left scientists baffled. Launched from Cape Canaveral on August 12, 2018, the Parker Solar Probe had one goal: make 24 up-close orbits of the star and study the sun's atmosphere, also known as the corona. Right now, the probe is doing just that, flying by the sun in ways no craft has ever done before. 3.7 million miles. That's how close Parker is getting to the sun. That might seem like a huge distance away, but it's incredibly close compared to anything that's come before it. In fact, it's 8 times closer than any previous spacecraft, and nearly 9 times closer than the planet Mercury. So what is the purpose of the probe aside from breaking records? It was made to study the heat and energy from the sun and how they move through the corona. Parker was also created to study the solar winds that come from the sun's surface to see what accelerates them and where they originate from. Simply put, the Parker Solar Probe is there to answer questions about the sun, solar physics, and solar winds that scientists have been asking for more than 50 years. In fact, back in the 1950s, a probe like this was proposed, but as you can imagine, science hadn't caught up with the dreams of scientists, and there was no feasible way to create a spacecraft that could withstand the heat from the sun. It's the solar winds that are the heart and soul of Parker's mission. Solar winds are a collection of charged particles that stream from the sun and flow past Earth at speeds of more than 1 million miles per hour or 1.6 million kilometers per hour. These winds can affect our planet's magnetic field and create something known as space weather. Space weather is the energy that courses through space and can impact or even destroy our satellites. Our man-made satellites are vital for all of humanity, powering everything from television to cell phones to weather reports and plane trips. Now you can imagine why understanding solar winds and space weather is so important. One of the craziest things about solar winds is that there is no discernible cause for them. There is no organized wind close to the sun's surface, but they are still being ejected from it somehow. You have to remember that the sun isn't like Earth. It doesn't have a solid surface. Instead, the sun is a molten, churning mass of burning heat that is kept together by the immense gravity of its course. The sun is so large and so dense that anything even remotely close to it is grabbed hold of by it. Yet somehow these solar winds are able to escape from the sun's gravity and then build up speed that allows them to jet through space at millions of miles per hour. Scientists believe there is some unknown factor that is accelerating these massive waves of wind, and the Parker Probe is in the business of finding out exactly what it is. Then there are the questions behind the sun's corona, which is something else the Parker Probe is digging into. The corona is essentially the atmosphere of the sun. It has an incredibly wide radius that reaches out millions of miles. The area in which the sun's gravity and magnetic field suck in anything around it is called the Alphen critical surface. Scientists have long known of this point of no return, but until now they could never figure out just how far away from the Sun it travels. Previously, scientists have thought that the critical surface was somewhere between 4.3 to 8.6 million miles from the surface of the Sun, or about 10 to 20 times the radius. But as it turns out, Parker has shown that it's about 8.1 million miles above the Sun. The Parker probe is looking into the corona because this is where we will learn most about the solar winds flowing from the star's surface. For instance, it already learned a lot about the corona. Parker revealed that it's not just a smooth circle around the Sun, but instead it has a series of enormous spikes and valleys. This information is a major step forward to understanding what propels solar winds. Despite being millions of miles away from the surface, the Parker probe couldn't spend much time being this close. That's because even the corona is scorching hot. In fact, for some strange reason, the corona is actually hotter than the Sun's surface. The corona is 1 million degrees Kelvin, 1.8 million degrees Fahrenheit, while the star's surface is a comparatively cool 6,000 Kelvin. Now, how does that work? Why is the corona around the Sun actually hotter than its surface? That's just another question the Parker Solar Probe is looking to answer. Even with 4.5-inch thick carbon composite solar shield, the probe is having to be very careful with its time in the corona. That's why it is completing its mission in a series of huge swoops that bring it close and then back away into safety. By the time Parker finishes its journey in 2024, it will have made 21 close approaches to the Sun over the course of 7 years. At its closest flyby, the probe will orbit within 3.9 million miles of the Sun's surface. Scientists equate that with being on the 4-yard line of a football field while the Sun rests in the end zone. Yes, it really is that close. The Parker probe will happen to be close to the Sun during a critical time in its 11-year cycle. Every 11 years, our star completes a solar cycle of calm and stormy activity and then starts a new one. Luckily, the Parker probe will be able to better understand the Sun's cycle, which has a direct effect on solar winds and nearly everything else related to the Sun. The current solar cycle we are in started in December 2019 and will peak in July 2025, meaning Parker will catch the tail end of it. For all the hard work that Parker is doing, there will still be countless mysteries about the Sun, which means that hopefully this probe won't be the last one sent by NASA. But the information currently being dug up by the Parker Solar Probe is still giving us so much insight into how the Sun works. It seems that NASA keeps pushing the limits of what we know is possible. And the same can be said about their newest piece of technology, the James Webb Telescope. Make sure to click the video on your screen and I'll show you how NASA plans to look deeper into the universe than ever before. I'll see you there.